In this video, we are going to cover statistics versus parameters, population, and sample versus sample. In the world of data analysis, we often encounter two terms, statistics and parameters. They both describe characteristics of data, but they serve distinct purposes. Today's presentation will shed light on those fundamental concepts. By understanding the differences between statistics and parameters, we can become more effective data interpreters and make informed decisions based on our findings. Statistics unveiling the sample. Imagine you want to know the average height of all students in your school, that is population. It would be time consuming and impractical to measure everyone. That's where statistics come in. We can select a representative sample of students, for example 100 students, and measure their heights. The average height we calculate from this sample is a statistic. It is an estimate, not the absolute truth, but it provides valuable insights into the likely average height of the entire student population. It is important to remember that statistics can vary depending on the sample chosen. If we pick a different sample of 100 students, we might get slightly different average height. Parameters, the population truth. Parameters are like the holy grail of data analysis, the true values we seek for the entire population. Going back to our student height example, the average height of all students in your school is a parameter. This is the fixed value we would love to know, but unless we measure every single student, it is not practical to determine it directly. While parameters represent the ideal scenario, they are often not readily available. This is why statistics calculated from samples become our best tools for approximating population characteristics. Just like mathematical formulas have symbols, statistics and parameters have their own notation. This notation helps us distinguish between estimates, statistics, and true population values like parameters. Statistics are generally represented by lowercase letters. For instance, x bar, read x bar represents the sample mean, s represents the sample standard deviation, and p hat represents a sample proportion. On the other hand, parameters are denoted by uppercase letters. The population mean is symbolized by mu, the population standard deviation by sigma, and the population proportion by capital P. Understanding this notation is crucial for interpreting statistical analysis and reports. Let us bring these concepts to life with a real world example. Imagine a city with a population of 10,000 people that is population. You are interested in understanding the average income mu for all residents. However, collecting data from every single person would be a monumental task. This is where statistics come in. We can select a representative sample of residents, say 500, that is sample. By surveying this sample, we can calculate the average income X bar for that group. This sample average is a statistic, an estimate of the true average income mu for the entire city population. The bar chart on this slide depicts this scenario. The blue bar represents the average income calculated from our sample of 500 residents. The green bar represents the estimated average income for the entire population of 10,000, which is a parameter we cannot directly measure, but can approximate through statistical methods using the sample data. Thanks.